In this lesson, we are going to learn how to solve more complicated trig equations. Here we are asked to solve for x, if 2 to the power of tan x equals 32, and x lies in the interval 0 to 360 degrees. The first thing we need to do is to rewrite the equation in the correct form. If we rewrite 32 as 2 to the power of 5, we end up with two powers with the same base equal to each other. We can then drop the bases to get that tan x equals 5. This gives us a very easy equation to solve. We begin with the following calculator work to get an angle to work with. Correct to one decimal place, we get the angle 78,7 degrees. The general solution for this equation is therefore 78,7 degrees plus k 180 degrees, where k is an element of the integers. Let's now use this general solution to find all the valid solutions that lie in the interval 0 to 360 degrees. When k is equal to 0, we get 78,7 degrees, which is a valid solution because it lies in the interval 0 to 360 degrees. When k is equal to 1, we get a second valid solution. These are the only two solutions, because if we let k equal 2 or any other integer value, we will get solutions that lie outside the interval 0 to 360 degrees. This completes the question. Here is the next question. We are asked to find the general solution for cos x times sin x minus 1 equals 0. Because we have the product of two factors equal to 0, we can put each factor equal to 0, giving us two simple equations to solve. On the left, we can immediately do the following calculator work to get an angle for our general solution. The angle is 90 degrees, which means the general solution is plus minus 90 degrees plus k 360 degrees, where k is an element of the integers. On the right-hand side, we first need to rewrite the equation by adding 1 to both sides. We then do the following calculator work to get our angle. Again, the angle is 90 degrees, which we can use to write down the general solution for sine. And after simplifying, we get 90 degrees plus k 360 degrees twice. We therefore have 90 degrees plus k 360 degrees in all three answers. The final answer, which contains all the possibilities, is therefore plus minus 90 degrees plus k 360 degrees, where k is an element of the integers. This completes the question. Here is the next question. We are asked to find the general solution for 2 cos squared x minus 3 cos x minus 2 equals 0. Because this is a trinomial type equation, we can begin by factorizing the left-hand side as follows. We then put each factor equal to 0, giving us these two simple equations to solve. Next, we rewrite each equation in the correct form. In other words, cos of an angle equal to some number. Here you need to be wide awake. Cos x equals 2 has no solution, because cos x can never have a value greater than 1. We therefore only have one equation to solve. Let's do it. Step 1, as always, is to do the following calculator work. This gives the angle 120 degrees, which we can use to write down the general solution. This completes the question. Here is the next question, which is quite different to the ones we have just done. It is different because we have sine on both sides and two different angles. In cases like this, we can immediately write down the general solution as follows. Please note, the angle on the left-hand side is written on the left, and the angle on the right-hand side is written on the right. Next, we use algebra to solve for x. On the left, I subtract x from both sides and add 20 degrees to both sides. We then divide both sides by 2 to get x on its own on one side. Please note, I also divide k 360 degrees by 2 in this step. On the right-hand side, we begin by removing the brackets around the angle being subtracted from 180 degrees. Next, we clean up, and then add x and 20 degrees to both sides. We then divide both sides by 4 to get the final answer. Please note that I also divide k 360 degrees by 4. This completes the question. Here is the next question, which is similar to the one we have just done. It has tan on both sides as well as a minus in front of one of the tans. We can immediately write down the general solution. Again, we write the left-hand side angle on the left and the right-hand side angle on the right. But we need to be careful here. Can you see why? We must not forget to include this minus sign in the general solution. It is very important. We are now ready to simplify. First, we remove the brackets around the angle being added to 180 degrees. Next, we add x and 15 degrees to both sides. And then we divide both sides by 2, not forgetting to also divide k 180 degrees. We are now ready to use the general solution to find all the valid solutions that lie in the interval minus 180 to plus 180 degrees. If we let k equal minus 1, we get the first valid solution that lies in the interval. And if we let k equal 0, we get the second valid solution. K equals 1 gives the third valid solution. And k equals 2 gives the fourth and last valid solution. This completes the question. Here is another type of equation you may be asked to solve. In this example, sine and its cofunction cosine are given. Step 1 is to get the same function on both sides. To do this, we need to use the cofunction identity, which states that sine theta equals cos 90 degrees minus theta. We then simplify the right-hand side and get an equation with cos on both sides. The equation is now ready to solve. We can immediately write down the general solution as follows. In other words, the left-hand side angle on the left, and plus minus the right-hand side angle plus k 360 degrees. This means we will need to work with the following two equations. Let's go on to simplify them. On the left, we begin by getting rid of the brackets around 130 degrees minus x. We then subtract x and 10 degrees from both sides. This completes the left-hand side equation. On the right, we need to add x to both sides and subtract 10 degrees from both sides. We then divide both sides by 3, not forgetting to also divide k 360 degrees by 3. This completes the general solution that we were asked to find. Here is the last question. We are asked to solve for x if sine 2x equals 4 cos 2x, and x lies in the interval minus 180 to plus 180 degrees. In this example, we need to be careful. Even though they give us sine and cosine, we cannot use the method we have just used. This is because of this 4 in front of cos 2x. We can only use this method when there is a 1 or a minus 1 in front. In cases like this, you need to divide both sides by cos 2x. Can you see why I do this? Because then we can apply the quotient identity to get a very simple equation to solve. Let's do it. Step 1 is to do the following calculator work. Correct to the nearest degree. This gives an angle of 76 degrees, which we can then use to write down the general solution. But please be careful. The angle we are given is 2x, not x. This is important. After simplifying, we get that x is equal to 38 degrees plus k 90 degrees. We then use this general solution to find all the valid solutions that lie in the interval minus 180 to plus 180 degrees. I hope you have found the lesson useful. Good luck with the test.